Ever wondered how you got to communicate with your distant friends and family? Or how you can access information regarding anything with just a few taps on your phones? Or how you just found this video? Well, this video will brief you on how touchscreens work. What enables smartphones, tablets, and many types of information appliances to dominate as a technology? To be so critical and integral part of our lives that I would rather lose my keys or wallet than my smartphone? The answer to this question is a combination of app development, carrier networks, wireless internet, and interactive touchscreens. A touchscreen is an electronic visual display that can detect the presence and position of touch within the display area. The touchscreen enables the user to interact directly with what is displayed and, if the software allows, to control how it is displayed. For example, zooming in to increase the text size. Touchscreens are common in devices such as game consoles, PCs, electronic voting machines, point-of-sale systems, smartphones, etc. The popularity of smartphones, tablets, and many types of information appliances is driving the demand and acceptance of common touchscreens for portable and functional electronics. Historians generally consider the first finger-driven touchscreen to have been invented by E. A. Johnson in 1965 at United Kingdom, which was a capacitive touchscreen. In 1970, the first resistive touchscreen was invented. The first commercial computer was introduced by HP with Sony CRT surrounded by infrared transmitter and detector in 1983. The first cell phone with touchscreen technology was invented by IBM, that is International Business Machine Corporation, in 1993. Let us understand the working of a capacitive touchscreen through an example of a device which is close to our hearts, our smartphones. There are three different technologies in the touchscreen display which are all combined on top of each other. Let's get into the layers of the touchscreen display one by one. On the top, we have the protective glass or chemically toughened glass, which is 5 times stronger than normal glass. Before the introduction of iPhones with glass screens in 2007, the standard for all mobile devices was plastic. Although plastic is shatter resistant, it is very easily scratched, therefore not much durable. The atoms in a glass screen are compressed, therefore much more force is required for the glass to break. Below the protective glass is a projective capacitive touchscreen that senses the presence and location of a conductive material, for example your fingertips. It consists of two transparent diamond grid patterns which are made of indium tin oxide, which acts as a conductor and a clear insulator between them. If we consider that one of the diamond grids consists of a large number of electrons, this generates a negative electric field on the same diamond grid, which causes the same number of positive charges to build on another diamond grid. This whole setup is called a capacitor. Now if we move our finger close to this capacitor, it disrupts the electric field, which changes the number of positive charges in one of the diamond grids. This change is measured and the processor registers this as a touch. The location of this touch is detected by scanning charges or voltages along the column of one of the diamond grids and the rows of another diamond grids. This charge or voltage scanning is done in quick succession, so the processor can register multiple touches at once. Below the capacitive touchscreen is a display which uses OLED technology. Now OLED stands for Organic Light Emitting Diode. OLEDs are used to create digital displays in many electronic devices, and they generate high quality images that we see in a smartphone. The quality of an image depends on the pixels of an image. Basically, the higher the pixel, higher will be the quality of the image. Modern day smartphones have over 3 million pixels, meaning that there are around 10 million microscopic, individually controllable RGB lights at the palm of our hand. Just imagine the level of engineering required to control and manufacture that many microscopic lights. We definitely take technology for granted.
Touchscreens have become ubiquitous. They are used in vending machines, gaming devices, and almost every mobile phone on the market. With ever-growing surge of touchscreen technology, it's rather easy to miss the many uses and variation and how each configuration works. So let's see the types of touchscreens. First is capacitive touchscreen display, which we have discussed earlier. Second is resistive. Third is infrared display. And fourth is surface acoustic wave SAW display. Let's see resistive touchscreen display. This display features a glass panel with a unique resistive coating and a thick polyester conductive cover separated by small transparent insulating dots. When screen is pressed, then the layer makes electrical contact and a touch signal is noted. These displays are very rugged but don't last for longer period. Let's talk about infrared touchscreen displays. Infrared displays use infrared rays to detect touch signal and location of the contact point on the screen. They are ideal for harsh industrial application because it doesn't wear out and last long. Surface acoustic wave display uses ultrasonic waves to detect touch signal and location of the contact point on the screen. These are very sensitive to touch and can differentiate between a hard touch and a light touch.